This video is to address on issues that could help people who want to solve block diagrams to solve it easier. Alright, block diagrams reduction. Alright, if you happen that you try a lot of times and you still fail getting the answer, then I hope that this can really help you in solving any block diagrams. Alright, but if you are looking for something that is basic, you don't even know what is block diagram, then I would just suggest that you watch this video and check things out a little bit. Alright, this is the basic of the block diagram. And if you want to get a feel of the reduction method, click this link. Alright, it's from Gordon Parker. Alright, nonetheless, if you want to search for anything, just search for Mason rule block diagram. You should be getting all these links all there. Alright, but lastly, you can just click this link and check this out. But the explanations is a little it's good, yeah, but I didn't learn this method from my school, and therefore I don't know whether other people who learn from other schools may understand this, and therefore, yeah. And to start off with things, let's just do this question. Alright, there is 4 things that I always remember when I do block diagrams. Alright, you're taking something, you lose something. When you take out something, you gain something. When you see something squared, something is wrong, blah blah blah. Alright, I'm gonna go through each of them, and then you get to know and get a feel of what are the things that should be considered. Alright, so when you're taking something or you lose something, what do I mean by that? Alright, for this block diagram, if I want to simplify this, for goodness sake, I will just bring this thing out. Alright, if I were to bring this thing out, so I'll just reconnect this thing. So when I bring out G, so if I gain G4, you see, I eat away the G4. Alright, G4 is being brought into this loop over here. Alright, if I were to bring G4 in, alright, I am losing something because I'm gonna provide him more food, right? If I bring in a new G4, I'm gonna give him food. So therefore, H2 is gonna divide by G4. Alright, this is why I assume that you know the basics already, so when I explain, you know what I mean. Right? If you don't know what I mean right now, then this means you don't know the basics yet. Alright? Because sometimes you don't know when do you use H2 G4 or whether is it H2 over G4. This is the key concept. If you take in something into the loop, you lose something. That means divide. And when you take out something, you gain something. Okay, for example, if I were to take out G3, if I were to bring this loop out, alright, if that is the case, then this is H2 G3 because I take out this thing over here. Alright, as you can see, when you take out something, you gain something, you multiply by that something. When you bring in something, as what we shown over here, alright, you're gonna lose something, you divide by G4. This is the first philosophy or first type of method that I remember things. Alright, now since the next thing you need to do is to settle this loop. So remember, solve loop by loop. Don't one shot solve everything. You don't think you're very capable, you don't do all short of, or perhaps not, you don't think that everything comes together as a set and then you just solve as a set. Solve this thing first. Alright, be patient. Alright, you can solve this thing first, and then later on you add this thing or something like that. Solve each of them individually first, at least you don't have any careless mistake. So if I were to solve this thing first, G3, G4, alright, this is the forward loop, divided by 1 plus G3, G4 times H1. So it's gonna include this everything. So at first the numerator is just like that. The denominator includes everything. That's the thing. You have the 1 plus something. This is the rule. If you don't know anything about it, please watch the video. Alright, and therefore I'll just rearrange, and I'll just write this thing as G3 G4 1 plus G3 G4 H1. Alright, and please take note that if the feedback loop, alright, just take a look out only. If the feedback loop is minus, then it's 1 plus G3 G4 H1. If it's a feedback loop that is plus, then it's going to be 1 minus G3 G4 H1. Alright, so be very careful of what is the sign, and don't be confused by the feedback loop. This is a feedback loop. You're going to feedback to this thing. If it's a forward loop like this, you see there's a plus over here. This is simply, you don't need to change the sign, because it's the forward loop is feeding, it's plus. If it's plus, it's plus. If it's minus, it's minus. Alright, if it's feedback loop, if it's minus, then this is plus. If it's plus, then it is minus. So feedback loop is totally different from the forward loop, so be very extra careful on this thing. Alright, and next, as I said, I'm gonna rearrange this as G3 G4 and stuff like that, so on. Alright, so this is it, and therefore the next thing I'm gonna do is to include this G2 inside. So simply I'll just multiply it in, right? And therefore what I will have is G2 G3 G4 1 over blah blah blah. Alright, now again, remember solve loop by loop, don't one shot solve everything. Now this is another loop, this is another feedback loop, so you're gonna solve again, right? This is why I say that this is very important, because if you one shot solve everything, you're gonna miss out something. Alright, so I have G2 G3 G4 over 1 plus G3 G4 H1. Alright, this is the forward loop, it's going forward, divided by 1 plus, alright, everything that is in the forward loop. So the feedback loop is just like this going on. And remember, take note, this is minus now. It's the feedback loop. Feedback loop, if it's minus, is the plus. Alright? And therefore we have plus over here, multiply by H2 over G4. Alright? This is the one that I've just written it down over here. Alright? And therefore take a look. This is very hairy. When you see something that is something hairy, is okay, because you can make it more simple. At least it's something not square. Squared means that if you have like G3 square, G4 cube, you will know that there's something is wrong. Alright, so if you see that it's pretty hairy like this one, like don't know what the hell, at least this is something safe. So what I will teach you some algebraically method. Alright, so if you have simple case, a over b 1 over is equals to a b plus a. If you don't know this concept, I'll just share with you this concept. You just multiply everything by the denominator b. Alright, so if you have that, you have b over b, which is equals to 1. So therefore you didn't change anything of the equation. Alright, you're just manipulating with the variables, and therefore I would have ab over b 1 plus ab over b, and I cancel. I would have a b plus a. In fact, this is b because this b multiply with the denominator, this b multiply with the numerator. Take a time to download this thing, because it's if you really need to do block diagram, this is something that you will soon need. Alright, because I think you will transition into controls, alright, where things will become, or modeling, things will become more hairier. And therefore if I have this thing, I'll just multiply as what I've just done earlier. Alright, but beforehand I will know that this G4 can be cancelled out each other, right? G4 can cancel out, and just multiply H2 inside, okay? And therefore now I multiply all the denominator, all this stuff over here. At the first time you may be feeling very tough, but soon in the future you'll feel like you're a king. I'm just exaggerating. Sometimes I also cannot solve some things. Anyway, so now this is simply equals to 1, so I didn't change anything, I just simply manipulating stuffs. So therefore I would have this thing cancel off with this thing, and then this thing will multiply with 1, and then this thing will cancel off with this. I'm just simply doing that. Alright, I hope that this is pretty clear, because just now the A over B, never mind, I'll just do it for you because I scared that you really don't know what the hell am I talking. Alright, so I'll just zoom in up a little bit and then rearrange. So when I multiply this into this term, alright, I'm gonna place it over here right now, okay? And next, I'm gonna take this thing and multiply each other. I'm gonna multiply into all this stuff, so I have this over here and on top. Pause the video a while, hold on. So this is it, and don't be intimidated by that. It's just because I just want to show you. It's just simple as the A over B. 1 plus A over B is equals to A over B plus A. I'm simply multiplying B's only, A over B, then changing this, all the stuffs. That's all. Alright, so you just take a look, concentrate, and things should be fine. Concentrate and trust me, my friend. Anyway, so if I were to multiply this thing onto the numerator of that, I will have this thing over here, right? And I multiply the denominator to all these numerators, right? Because imagine they are all isolated in one room, you're just multiplying them in one set like that. And therefore this thing cancel, this thing cancel, this thing cancel, this thing cancel, and there you go. You have a G2, G3, G4 over 1 plus G3, G4, H1 plus G2, H2, beta boon. But anyway, you're just trying to simplify this into here, and that's all. Alright, so I gotta replace this thing as the loop over here. Alright, so hold on, and therefore I'm just simply rewriting that term. If you happen that you forget what I've written, I'm just simply rewriting this form as form, which is what we have just solved earlier just now. And just to let you know, if you feel that you have lost your loss, or you don't know what the hell am I talking, pause the video, go back a little few minutes, replay it again, take out a paper, write it down, do something, you will get it right. Alright, and just now this is G1, I just multiply it in, right? And therefore if I just multiply it in, I'm expanding all this stuff, I have G1 over here. Alright, and just cancelling this off. I'm just multiplying the block diagram. And for example, if you don't know what the hell am I talking, just right now is what's G1 times something. For example, this is just the rule itself. G1 G2 is simply equals to G1 G2. That's all. Okay, this is just a rule. If you don't know how to apply, this is how you apply the rule. Okay, and therefore, okay, so what should I do now? Good job. Yeah, so now this is a feedback loop. Now we're gonna feedback again, right? You're gonna take this dude. Now I'm gonna copy this, and then as you can see, this is a feedback minus. So feedback minus, you have 1 plus, right? So I would have this whole thing divided by 1 plus, and then this thing, the forward loop, and includes this h3 over here. Alright, simple as that. Okay, or I should just write h3 over here for simplicity's sake. So we should, and so you should be familiar with this form now. Again, you should be confident. Although this is very hairy, at least you know what the hell. I'm just cancelling out each other. Now this is a cheat code. Alright, I assume that you're already professional in terms of this type of things. So I'll just straight away, boom, go in. I cancel away this. I bring this term. Alright, bring this term over here, and there you go, bang, that's the answer. Okay, if I were to rewrite it for neater way, for because you can see properly, we have this answer over here. This is your transfer function, right? So this whole chunk, now this whole piece over here is simply this one. So I can just simply write the whole block diagram as like that. Alright, so this is your output and this is your input, and that's it. This is the answer. So what is it that I didn't go through is this one. Use Mason's gain rule to check. Alright, how do I check this thing? So I'll just simply paste the block diagram, the initial one that asks us to simplify. I'll just paste it over here. Mason's gain rule is pretty simple. Alright. Sorry. It is simply forward loop divided by 1 plus the summation of all other loops, feedback loops, I would say. So what does this mean? Forward loop, bam, you have G1, G2, G3, G4, alright, which is what is over here. Multiply everything together, bam, that's it. Divided by 1, because it's a feedback now, 1 plus summation of all other stuffs, alright. So take note now, all other stuff is what? The feedback loop, right? So let me see, we have, let me take a darker color. We have one loop over here, feedback loop. We have a second feedback loop over here, and we have the super ultra big feedback loop over here. Alright, 3 feedback loops. So take a look, the first one, the blue color one, we have G2, G3 and H2 with a minus. Minus means plus sign. We have G3, G4, sorry, G2, G3, H2, alright, which is this loop over here. So we have identified that, alright. Now, next, green color one, which is this one, G3, G4, H1, right, G3, G4, H1, and then also is minus, so we have minus feedback. If it's minus, it's plus. And therefore we have plus, what am I doing? Plus G3, G4, H1, which is this loop over here. Pretty simple. Purple color, the freaking hell big loop. Feedback loop minus also, which is in fact plus. Meaning, I think you get what I mean, okay? So therefore, plus G1, G2, G3, G4 and H3. So I have G1, G2, G3, G4 and H3, this whole loop over here. And this proves that we are correct. As you can see, Mason's gain rule is very straightforward, but normally in the test they want you to derive this thing. So this is why I've go through all this thing to share with you what I know. And these are the 4 things that you should go and check it out. And additional stuff is this, alright. I just want to stress again, okay? I just want to stress again because I feel that this is very important, alright? Careless mistake often comes in here. Just a quick review, so at least you know what the hell am I talking about in the whole everything is, alright, just rewrite this clearly, so at least you know what I mean. What is this if we were to write in terms of transfer function? Take a time, tick tock, dang. Alright, it's a 1 minus AB. Take a look, it's plus sign right now. The feedback is a plus, so you need to minus. And you may wonder why my feedback is plus and I want to minus. Alright, imagine you send a 5-volt electricity, alright, out to some systems, and before it reach out to this system, it feedback here and say that you have 7 volt. On the next submission or transmission, you're gonna reduce, and because you're gonna reduce by another 2 volts, alright, because along the way something may have changed the quality of 5 volt. Maybe this has 2 volt over here, so together they become 7 volts, alright. But this shouldn't be 2 volt, alright. Just in terms of, it should be 7/5, alright. But just to convey the idea is that along this way you may actually alter the input and change it to something different, and if you feedback slightly more stuff, you're gonna change this value, which is you're gonna minus somewhat lesser stuff, so that this thing can be reduced. So therefore, if you have plus 2 volts in this case, because this is total 7 volt, okay, 5 volt plus 2 volt is equals to 7, and therefore you have a feedback of plus 2. So we want to minus away this in this one, so that we can have something that is pretty cool. I hope that this is kind of clear to you, that why is there a plus and minus. But however, now this plus is always plus, okay? It is always plus, but when does it becomes minus? What type of questions will it ask you to become minus? You have something like that, take a look. You're going forward, you're going in this direction, you see. So there is some often careless mistake that when you see this type of thing, you think that it is a feedback. It's not going in this manner, it's going here now, alright. So therefore, if you were to deal with things in terms of parallel, this is A minus B, alright, because this is plus A forward loop minus a B forward loop. So we have A minus B. If this is plus, then we will have A plus B. So this is the thing. And let me ask you another question. What if I have C feedback with minus? Then simply say the forward loop is just A minus B, alright, which is what we have just said. And then 1, because this is minus now, we have opposite sign plus, alright, A minus B, the whole thing, because this is our feedback, C, and that's it. And I hope that this summarizes all the stuffs that are relevant and really important to you in block diagrams. I know this may not be exceptionally helpful to you, but that's all. Goodbye. Have fun. Enjoy.